Okay. I used to have one. T-test for dependent means we just did a t-test, yes, but what is the difference between the t-test there and here? That t-test is for independent means or a one sample mean. If you look in chapter 3 of our text, a regular t-test, we looked at one sample case. Let's say previously. It's like a show.
Yes, oh my god, that makes it so fun. Okay. Excited.
We're really invested now.
Yeah, it's pretty easy.
Okay, so only today.
But in post the bill, it's gonna be days from now.
But okay, I see a point. I'll put the date.
Yeah.
So one sample case is what we did previously. We simply tested for a mean. So the null is mu greater than equal to 0 against the alternative. What should the alternative be? I'll use not equal to 0. A simple case because we have mu to be an average that comes from a single sample. Of course, it has to satisfy all assumptions, normality, random sample, identically distributed, etc. Same will apply here. Fine. So we're going to use the CHIPS data from BSDA. We're not talking about chips that we eat. Integrated chips, computer chips. So when chips are done, you've got to put layers and layers of silicon, not cone, silicon dioxide to form an integrated chip. So what they have here, we will come back to this later, but they have 30 observations. In other words, you have 30 values recorded, but they have first measurement, second measurement, third measurement, fourth measurement. For the first wafer, same first, second, third, fourth measurement for the second wafer. So you have 2 of them. And with the same wafer, they are going to repeat the test. What are they testing for? Thickness of the oxide layer. So we are going to pick wafer 1.
So is a wafer like considered a layer?
Yes. Thin layers of silicon dioxide. So if we consider wafer 1, the same wafer is subjected to 4 measurements. Yes. So if I find, let's say, an average thickness of oxide layer for the first wafer, first measurement, and then I looked at the average thickness for using the second measurement, do you believe that the measurements are related?
I would say probably, but then you say that's not a yes or no answer, so I have to give.
You're learning, Cleo. So the first measurement and the second measurement are related to each other. So this is a dependent case, and you are repeating the measurement, correct? In experimental design, this is what we call a repeated measure state design. Now, marine science people, if you did an experiment, this is what you would do. Good example, say algae, right, the top thing, you would probably have 4 different lots, for instance, at different areas of the river. And at each lot, you would replicate the measurement over and over. That is simply repeated measures. So I'm not going to look at all 4 measurements. Let's look at the data. That's the first thing that one must do. So data chips. Ooh, look at that. So those are the data values that I have. So wafer 1, first column, first measurement, second column, second measurement with wafer 1. They are related to each other, so they are dependent. If there is consistency, what would one expect between the first measurement and the second measurement? So they have to be the same, right? But are we dealing with deterministic things, things that are not random? No, we are dealing with random processes. So there will be variation between these 2 measurements. I just want to see if there are no differences, are we being statistically significant in making that conclusion? Good. So when you make an integrated chip, you've got to make sure that there is consistency. If the chip is broken, if you manufacture the chip incorrectly, laptop's not going to work. Your washer or dryer is not going to work. So we have 2 measurements, each of them 30 observations. Good? Okay. What we are going to do is to test and see. Oh. Does the average thickness of oxide layer differ between measurements 1 and 2 for wafer 1? Good. That is our objective. You cannot do a t-test, the one that we did, and say, oh, the wafer is consistent. That is wrong to begin with. Now, if you look at the way the design was done, you have wafer 1 repeated 4 times, wafer 2 repeated 4 times. We will probably talk about this way later. If you want to look at the article, it's right here, nested random effect model. It is a way to determine effects in a repeated measures design. So I believe your book does that. We'll come back to that later. I'm doing the simple case where I have repeated measures, same wafer, first set, second set. Of course, they are dependent. We will see what the conclusion will be next time. Good.